Okay, I'm probably going to get in trouble for this, but I'm going to do it anyway. I'm going to turn the mic over to the head of the planetary division, Dr. Jim Green.
Thank you, Dwayne. The one question I have then, based on the observations and what you found out today, is would you say that Mars was habitable before or about the same time as Earth was in the history of the solar system?
That's a good question, Jim. I'm not sure we'll ever really be able to address that with our payload, but you know, we've got a couple of different options here for the age of you know, just relative to Mars, how old these things are. And quite frankly, they go between being as young as that alluvial fan lobe that comes down, which I think would be relatively young in the history of Mars. And it could be quite old. Maybe these rocks are somehow related to the base of Mount Sharp. We can't rule out that we're not looking at the base of Mount Sharp right now, in a way. So we got a lot of options open before us, but I think in any one of those versions, we're talking about older than 3 billion years ago. And we're probably looking at a situation where plus or minus a couple 100 million years, it's about the time that we start seeing the first record of life preserved on Earth. It's a great comparative planetary question.
Make a good reporter, Jim. Make a good reporter. Okay, let's go back to the phone lines. Mark Kaufman from the Washington Post. Mark? Do we have Mark on the phone? Okay, let's move to Craig Covalt. Craig.
Hi, this is Craig Covalt with SpaceRef Curious Mars. A question on the clays. If one of the more significant findings is that you had abundant water flow through the clay, how does that relate to meteorite findings where they have also identified significant water clays found in Martian meteorites? Then I have a follow-up.
I didn't quite catch clays, white water, and then how does that relate to Martian meteorites particularly?
Well, I think, you know, the clays in Martian meteorites were just almost trace quantities, and the Martian meteorites that we've seen are mostly purely igneous rocks. The clays in this rock, which is a mudstone, which was something deposited in a shallow aqueous environment, are really a major percentage of the rock, and so they really represent a significant process. And plus, I guess you could call meteorites the ultimate what we call float rock. It came from someplace else, and we don't know where it came from. We know where this stuff came from. It came from this bedrock in Yellowknife Bay, and so we know that this environment existed in Yellowknife Bay with plenty of water.
Do you have a follow-up, Craig?
Question is, while I'm happy, there has been some chatter that you had a leak in one of your chemistry cells, correct?
Yeah, in the rock nest sample, we certainly detected some vapor that was very easily identifiable, a trace amount of vapor, nanomoles. That's the signature of what's inside our wet chemistry cells. And so one way or another, whether it was through a very small leak through one of the pinch-offs or processing, a little bit of that vapor is there. What we are doing is trying to get smarter about how we do experiments to avoid some ambiguity with regard to where carbon coming from our sample comes from. And so what we did with these rock nest samples was we preheated the sample and let helium flow over it for something like 20 minutes. And it's a very clear signature of all that vapor being flushed out of the system. So that's really a very robust way, we believe, of getting around this issue that we saw at Rocknest. Yeah.
Next caller, Lisa Grossman from New Scientist. Lisa?
Hi, can you hear me?
Yes.
Great. I was wondering if you could compare this to Enceladus or Europa or other comparative potentially habitable environments. Is this the most certain habitable environment outside of Earth that we've seen yet, or the first that we are definitely sure is habitable? Can you put that in other context?
You guys take it. Yeah, I'd go for it.
I think the answer is yes. I mean, I think there was a question earlier about what's the take-home message about this, and I think this is probably the only definitively habitable environment that we've described and recorded. I don't know, there are places we would suggest could be habitable, but we haven't measured there.
Yeah, and again, here we're poking at what happened a very, very long time ago. It's not a current puddle on Mars. Mars is now cold and wet, and a lot of the atmosphere has escaped, and some of the radiation may have processed samples that we're looking at. It's in some respects, it's a fairly harsh environment. And so the focus of the mission is a lot on what things looked like in the past. That's kind of the idea both of this mission, where you can get down and drill into the rocks and do the types of experiments we've described, but also kind of the intent of an upcoming mission, which is going to launch this year, MAVEN, which is trying to study how the current atmosphere is escaping, and then through modeling try and get back to what early Mars looked like. So all these things are part of a program, and they all tie together, but it sure is fun to dig in the dirt and try and understand the ancient environment.
I guess one way to look at this is with Curiosity, we've been able to take this to the next level of understanding whether or not Mars is habitable. It's not just a broad brush, oh yeah, there's water and yeah, there's rocks. We actually know there's particular environments that water was there for a significant amount of time, that it was neutral, it wasn't too salty, there's plenty of water to not act like honey, but in fact water for microorganisms to use if they were there. And the idea that we have oxidized and neutral species in this place. So as we look into the details, it looks better. And for that reason, I would actually agree with Dave and Paul.
Okay, we're coming up top of the hour. We're going to be wrapping up shortly. I want to come back here to headquarters to see if there are any questions in the audience. I'll take a couple of more calls on the phone. Any questions here? Can you wait for the mic, please, and give your name and affiliation? Sorry.
It's Kitty Faldy with KPCC Southern California Public Radio. I know discovery is the exciting part. You don't know what you're going to find. But what could you, with the equipment that we have and the range that you're going to have, I mean, what are the kinds of things we could detect that could even make it more specific? I mean, what could we possibly find that is much more provable than what you found and told us about today as far as habitable conditions, or finding some more clues about life on Mars?
Yeah. Let me use that as a chance to go into the issue about the deliberate search for organic compounds again. As I said earlier, we need this paradigm, and it has to be a Mars paradigm. We can start first with our understanding of Earth, but as I already said, there's the three parts. The thing that to me, I think many of us on the team, that seems the most familiar for this environment, which is an alluvial fan and possibly a lake that was there, that's very familiar. And we can think about mechanisms that would have generated carbon, even carbon that comes from outer space, that would have accumulated there. After that, it starts to get different. The one at the very end, on Earth, we have plate tectonics that tends to heat rocks up and destroy organic material. On Mars, we don't have that, but we do have radiation. The one in the middle is going to be, I think, the really fun one for the team, this process called diagenesis, because on Earth, we're used to a sort of a stable of compounds that we know about that can cause oxidation of organic compounds. On Mars, we've got a new cast of characters, some of which now are becoming familiar, things like perchlorates. There could be other things there as well that Paul and Dave will eventually tease out with their instruments that might be present there at trace quantities. And the question is, when you put those things in water and you add organics, how do they react in a way that might break them down? How fast does it occur? How aggressive is the reaction? And I think that's what I mean by comparative planetary habitability. We can begin to start to play that game now.
Okay, we're going to take one more question from the phone line, and then I'm going to invite Dr. Grunsfeld to come up for some parting words, and then I will conclude the briefing. And I believe we have Sky and Telescope. Camille, are you on the phone line?
Yes, hi. I'd be a bit of a long shot, but in December there was discussion might actually be some dust mound and not created. As far as goes, this sign of relate does it have any effect on
Camille,
how Mount Sharp?
Camille, could you please talk, repeat the question? You're kind of going in and out on here. Let's try that again. Can you repeat the question?
Sure. Let me try my hand. Is that better?
Yes.
Okay. At the AGU in December, there was discussion that Mount Sharp might be this sort of mound of dust, and it might not be from water eroding. As far as the scale goes, this former lake bed, is it a large enough scale that we can say how Mount Sharp was built, or is this pretty focused local?
I'll let the others chime in here, but we're actually not quite sure how Mount Sharp was built. And so the real evidence of how that happened is in Mount Sharp. And so what we're seeing now is what's at the base and what may have not necessarily pre-existed, but happened at the same time or even later, looking, here we are at Yellowknife Bay. But how Mount Sharp was formed, we have to go to Mount Sharp to see those layers to sort that out.
Yeah, I agree with Michael completely, and just give you a heads up that when we start driving to Mount Sharp and you see us dragging our feet as we go along there and stopping to look at a few things, that's because we'll be trying to figure out how the rocks we're at now at Yellowknife Bay relate to Mount Sharp. That's how we get the relative age of all this stuff.
Yeah, good point.
Okay, so before Dr. Grunsfeld comes up, I am going to take one question going back to the West Coast to the Jet Propulsion Laboratory. JPL?
Yeah, this is NBC LA. John, this question is for you. Back in November, you said that there was going to be, the news was going to be one for the history books. Did you know now what you know now?
We got chapter 1.
Well, I can tell you I feel better about it now. You do, when that kind of a thing, you do need to sort of ante up. I think, basically, again, that expression at that time was just simply looking at the second run coming out of SAM and realizing that the instrument did a replicate of what it did the first time, and that if you ever got it into the right place, this would all pay off really well. And so it's just having confidence in the science team to get the mapping and provide the direction of where to go. And it seems like that's what's happened, and I certainly feel really great about it.